Hi, my name is Rick Fleeter. I'm an adjunct professor here at Brown, and I'm doing this video to tell you a little bit more about Engineering 176 machine design in case you're interested in case you're thinking about taking 176. There's a lot of confusion about the course, which actually I took as an undergraduate in 1976. I thought that the best way to explain 176 might be to explain a little bit about myself and what I try to do with the class, which I guess 2012 will be my 10th year teaching it. After I left Brown, I came back to Brown and did my PhD and then disappeared to become an aerospace engineer, and I worked in that field and built a company to build small satellites. So I look at machine design from the point of view of an aerospace designer. When I took 176, it was taught by Professor Richardson, and he looked at 176 in terms of engines and thermodynamic devices in vehicles. Then in between us for a while, the course was taught by a naval engineer who looked at the course from the point of view of building boats. And for a long time the course was called yacht design. And so how can it be the same course if, you know, 1 year you're teaching engines, 1 year you're teaching... Well, the point is that the course is really about design, more than it's about a specific engineering discipline. And what we try to do, what I try to do, and what the TAs try to do in the course is take you into an area that maybe you don't know anything about and maybe you don't really think you care very much about. And I think that describes about 80% of the people who take 176. They don't really have a plan to be an aerospace engineer if they ever even really thought about it. And to me that is sort of a good thing, because the working environment that you tend to get into as a designer, as an engineer, someone walks in the door of your office and says, "We've got to do this," and you're thinking to yourself, "But I know absolutely nothing about that." And that happens over and over again. And that is what engineering is really about. It's not about knowing a specialty. It's about knowing an approach to analytical design which can lead to something which works and fulfills a certain set of requirements. And aerospace is valuable from that point of view, from the course's point of view, because most of the students are coming at it from kind of a blank piece of paper. So what we do in the course is every session, every week, we take a very quick look at one of the things that's involved in aerospace vehicle design, whether it's the control of the attitude of the satellite, which direction it's pointing, how orbit mechanic works, all the radio links, power, photovoltaics. And what I hope people see in the course is that these technologies are not unique to just the satellite environment, but having studied what are the problems involved in charging lithium-ion batteries or nickel-cadmium batteries, using that power, working out a power budget. I did a solar installation in my house, and I found all the problems extremely similar to those I've been solving for, well, to use an expression, for decades in the space world. In the goal of the course is not to hand you homework assignments every week. We do have homework assignments, but they're done in groups and they're not particularly graded other than that we'd like you to do them. The real objectives of the course are to come up with a design, and we divide the course into groups of students, usually 3, 4, 5 students, and they usually self-divide. Each one identifies something that they want to do in terms of a mission or an objective or a device that they want to demonstrate in space. And I give a lot of help about that. I give a million examples at the beginning of the course of different student projects. We also give projects from students done in the past to help you see what are the elements of a design that people have done. And then over the course of the semester, with the TAs and me, we work together in groups to work out all the problems of the design, and eventually at the end of the course have a presentation of the design and a build it project where you build some aspect of the design which is particularly interesting, particularly critical, particularly innovative, to demonstrate that you can build something, but to also demonstrate that this thing is actually interesting, actually works. One of the areas of confusion about 176 is who can take it, because if you read in the catalog, it seems to be a senior level course. It seems to have a bunch of requirements, prerequisites, which it does. However, we've had sophomores take the course, I've had juniors take the course, and I'd say most of the course is composed of seniors, not all of whom are engineers. We get physics majors, we get geo majors, and we've even had one RISD student take the course. Every student makes the contribution to the design that is sort of their contribution. And it's best when the groups have a variety of students, MEs, EEs, people from other backgrounds, because no one space vehicle design, like so many systems design, doesn't depend only on one aspect. I quite often, frankly speaking, will waive the prerequisites or make them into co-requisites because it's very difficult for students to have all the prerequisites done before they take the class. And I would say this class is pretty much orthogonal to anything else you've been taking at Brown, so it's nice to have the prerequisites, but not the outcome of your grade, let's say, is not heavily dependent on having taken the prerequisites that are in the course catalog. I recommend, if you're really interested in the course, but not sure, that you get in contact with me. The best way to reach me is rickfleeter@brown.edu, and you can find me in the engineering directory. So I hope you'll give 176 a good looking over and consider it for your schedule for second semester of 2012. Thank you.